Okay, so this is rational functions and zeros. It's going on page 35 when we're done. This says recall, which means we've already talked about it, or you should already know it. We have talked about it a few times. A rational function is a function that is a ratio, hence the word rational, of two polynomial functions. Think fractions. And there's an example. Variables in the denominator. Okay? So we really did explore polynomial inequalities previously in 1.5. Oh, holy cow. At least I did. I don't know what y'all were doing because the quiz didn't reflect very well on this. And so this is going to be the same thing as 1.5 basically, but for rationals. And it's not going away. All right? So we can utilize some of those concepts that we already learned in 1.5 to help us understand more about rational functions. All right, so let's look at two important traits of a rational function. So we have this function that's equal to a fraction of functions, right? A ratio of functions. These are both polynomials, and we've already talked about polynomials. And there's no factors in common, which means we've already reduced it if there was a whole, okay? When that happens, then f of x has zeros when g of x equals 0. G of x is the numerator, so basically that is the zeros of the numerator. Okay. Zeros of the numerator. That's the zeros of the function. We have talked about this as well. And f of x is undefined when h of x, or the denominator, is 0. And what do we get? What kind of information do we get from the denominator? What part of the function? If I have x minus 2 in the denominator, what do I have at x equals 2? Anybody? Anybody? I know y'all know this. If I have 1 over x minus 2, what's happening on the function at x equals 2? No, because I can't divide by 0. So what does that do on my graph? It's not a point. Anybody? Anybody want to look at their notes? I'm not moving on. What happens when we get the zeros of the denominator? It's a what? Yes, that's right. Say it loud. Vertical asymptotes. Yes. Do we know that? Yes, we know that. I knew you knew that. Okay. So those are our vertical asymptotes. Those are the zeros of the denominator. I know you know that. Okay. Right, so the zeros of the function come from the zeros of the numerator. The vertical asymptotes come from the zeros of the denominator, right? Because rationals are not brand new to us. It's not even the first time you've heard it when you heard it from me. Okay, I'm sorry, what? Where did we do it on the notes? I believe it was in like 0. It was one of the zeros. Nope, not that far back. Last week. Nope. 0.3. Yeah. Okay. Yeah, it was 0.3. All right. Okay. Let's refocus. All right, now look here. When solving rational inequalities, we need to identify both the zeros and the undefined values, which are our vertical asymptotes. And here's why. Okay, so you don't have to get your notes out for this, but we're going to go back and look at 1.5 because, I really did teach it. Where we did these sign charts. Okay, so the first thing we did here was factor. We found our zeros, put them on the lines, right? And then we checked our signs. Well, the reason we're doing that is because the only place a polynomial can change from negative to positive or vice versa is at a 0, because you have to cross through the x-axis. Does that make sense? So that's why we put the zeros on there, to see where we cross, or maybe we bounce. Maybe it was like this and it stayed negative. I mean, that's a possibility as well. But I had a possibility of changing from negative to positive there. For our rational functions, so here's the same function I've shown you multiple times. And we can change from, if you notice, you've got all of this that's positive, right? Then we have this vertical asymptote here, and then on the other side of it, it's negative. So I can change from positive to negative across a vertical asymptote. Oh, and still though, this function's negative, negative, and then once I get here, I cross through that 0, and now the function's positive. So in addition to the zeros giving us a place to change, we can also change across an asymptote. Now, not always necessarily. I could have a situation where it looks like this, and just because I have an asymptote doesn't mean that the sign changes, because maybe it stays positive or whatever. So instead of just putting the zeros on there, I also have to do the vertical asymptotes, which is what this statement is saying right here. Okay? All right, so our steps for solving. Number 1, make sure the inequality has a 0 on the other side. This is where a lot of people, way too many people, started making up math on that quiz. Okay? And the part that got a lot of people stuck had nothing to do with pre-cal. Nothing at all. This is the one that you had to do, x to the 4th minus 4x squared. You don't want to write this down because I'm going to scribble it out at the end. Just pay attention. X squared minus 4. And here's what I saw so many people do. It made me want to cry. You knew you needed a factor. A lot of those people even knew they needed to do some sort of number line, but this was the junk that I saw. I promise you, you haven't had a single teacher do anything remotely like that nonsense. If you are going to factor to solve something, what do you have to do first? Set it equal to 0. So y'all did this, and then you were like, well, I guess I'm going to have like a 4, and 4 wouldn't even be that. I don't know what happened then, and 2s, and then you just didn't know what to do because you're making up math. All right? I know you know better. I know you do. I think what happens sometimes is because it's the number line thing or whatever, you like assume things have to be difficult or assume that they're going to be different. It's the same factoring you've been doing forever. Okay? Do we all understand why this is not okay? Yes. Okay. Not okay. We have to make sure we have a 0 on the other side. And again, I know you know that. At least I hope you do. All right. So then we're going to make sure that our function, I just have a single rational function, meaning I don't have a rational and it's like +1 or something like that. If I do, then I have to get common denominators and combine them. I don't recall having seen anywhere you actually have to do that, so you don't really have to worry about that, I don't think. We'll revisit it if I find myself to be incorrect there. And then I set g of x equal to 0. That's the numerator, so that's the actual zeros of the function. And h of x equal to 0. That's where I'm going to get my vertical asymptotes. And those are the things that I'm going to include on my sign chart. Then I create a sign chart, which we've been doing. Be careful to mark the values where h of x equals 0, your vertical asymptotes, that we will never include those in our solution. Because you can't cross a vertical asymptote. You can cross a horizontal one, but not a vertical one. So it has to be an open circle all the time, which means it'll always be parentheses because you're not going to ever hit that asymptote. Then we test values, just like we did for the polynomials, to see if the intervals are positive or negative. We interpret it and answer, and be sure to write your answer in interval notation and think about the endpoints. And we're going to think about the endpoints at the beginning so we don't have to overanalyze things as we go through. Okay? Everybody good at this point? All right. So let's look at example 1 here. All right, so I got 0 on one side. I'm good to go. Then I need to factor it. It's already all factored, and I can't reduce anything. But what I can look at here is I can find my zeros. I have a 0 at x equals what? 2. Yes, from the numerator. And then my vertical asymptotes. I get x equals -6 and x equals 3. I can't list them like I could for the zeros because they're equations, so they're separate equations of lines. Everybody understand where all that came from? Yes? All right, so here's another issue that I saw with some people, and even though I'm going to say it, I know that whoever these people are, bless you, I never seem to be able to change them. don't make a little teeny tiny line where you have to put little teeny tiny plus and minus, then you can't even read your own stuff. You've got a lot of room. Let's make a long line here. And then I got 3 things to put on there. I'm just going to semi-evenly space them. They don't have to be perfect, and they definitely don't have to be to scale. But then I do have to put them in order from least to greatest. -6, 2, 3. Okay? Then, so here's what I know. I know for the vertical asymptotes, for these two, I have to have an open circle, regardless of anything else. Then, for my zeros, whether it's open or closed is based on this sign right here. And since that says greater than or equal to, is it open or closed? Closed. Very good. So I've got my circle here. Color that in. Okay, everybody with me so far? All right. So now I'm going to test some points. And you can't forget about the infinities on either side of it, because some people were kind of on the right track with them leaving these things off. So between negative infinity and -6, I can choose like -7. -7 minus 2 is a negative number. -7 plus 6 is a negative number. -7 minus 3 is a negative number. And then negative divided by negative times negative is negative. Wait, what? Yeah. Yeah, I just set them up, instead of like putting them all next to each other, I just kind of set it up as the fraction. It really doesn't matter, because whether you're multiplying or dividing, the rule's the same, right? Okay. We good? Y'all good over there? We good? Sure? All right, between -6 and 2, I can pick 0. So 0 minus 2 is negative. 0 plus 6 is positive. 0 minus 3 is negative. So negative divided by positive times negative is what? Positive. Then between 2 and 3, I can pick 2.5. I don't need the actual numbers, so I don't need to freak out that it's not a whole number. 2.5 minus 2 is positive. 2.5 plus 6 is positive. 2.5 minus 3 is negative. So overall, that is negative. Between 3 and infinity, I can pick 4. 4 minus 2 is positive. Then positive, positive makes the whole thing positive. Okay? Everybody with me so far? Okay, so what I'm looking for is when the function is greater than or equal to 0. So that means positive or 0. Here are the intervals. No, because I want it to be positive, so I'm starting at -6. So -6 to 2. Then I look at my line. This is open, so that's parenthesis. This is closed, that's a bracket. Then I go from 3 to infinity. I never include my infinities. 3 is open, that's a parenthesis. Okay? What questions do you have? For the polynomials, it's the exact same thing. Your function just isn't a fraction. Okay. We good? Yes? All right. So let's look at example 2. What do I need to do first? Factor. Okay, so I'm going to get x plus 2 times x minus 2 over, and then x and x, minus and minus. It'll be -5 and -5. Do we agree with that? And notice how I have a whole expression there, right, with the less than 0. Who is this? Oh, got it. Okay. Then I've got, so I need to clean this up a little bit, which means my numerator is x plus 2 times x minus 2, and the denominator is x minus 5 squared, okay? And then this is the one that I actually want to use because it's going to make my life a little bit easier, okay? And if you can recognize the patterns in the and the factoring, and you can go straight from here to here, that's fine. But if you don't recognize them, you can at least get there and then fix it. All right, so I'm going to draw myself a line. Oops, I got a little ahead of myself there, but we got zeros at x equals what? Good, plus or minus 2. And I could list them out, but, and then I have a vertical asymptote, excuse me, x equals positive 5, yes. So I have 3 things that go on here. 1, 2, 3, you have to put them least to greatest, like so. My vertical asymptote, which is x equals 5, is open for sure. Then my sign is just a less than, so what's happening with my zeros? They are open, very good. So everything's open here. Now I test some numbers. Between negative infinity and negative 2, I can do negative 3. And I'm going to use this one. So negative 3 plus 2 is negative. Negative 3 minus 2 is negative. Negative 3 minus 5 is negative, but I square it, so no matter what I put in the denominator, it's going to be positive, right? So I don't have to overthink the denominator anymore. And so negative times negative divided by positive is positive. Right? Then between negative 2 and 2, what would you pick? 0. Me too. So 0 plus 2 is positive, 0 minus 2 is negative, denominator's positive no matter what. Makes that negative overall. Between 2 and 5, I could pick 3. 3 plus 2 is positive, 3 minus 2 is positive, and the denominator's positive all the time, so that's positive. Then between 5 and infinity, don't forget those. I could choose 6. 6 plus 2 is positive, minus 2 is positive, and the denominator's always positive. This is what it looks like. Okay. Notice on the first one, it alternated minus, plus, minus, plus. This one didn't alternate as the last step. We'll talk about that a little bit more in just a minute. But I want this to be less than 0, which means I'm looking for negative, right? Here's the negative part right there. Yep, negative 2 to 2. Do I include either one of them? No, because I've already thought about it, and it's on my line, so I don't have to overthink it now. Okay? Ask me a question. What you got? Anything? Yes. Where you go? Oh, were you just pointing? Do you have a question? Why do we not include the 5? You mean, why is this not closed, or why is it not included here? In the end? Because I only want it to be negative, and this is the only part right here that's negative. Okay. Why is it? Okay, because it's the vertical asymptote, and the asymptotes, they're open no matter what. That's why these two were open, because these are my asymptotes. That's why these are open. We don't include them at all, because you're never going to, since it's vertical, you're never going to touch that asymptote, so you can't include it. Okay, good questions. Anything else? What else you got? All right, flip it over then. Alrighty. So on example 3, I've got 0 on one side. I can't factor or reduce it any more than it already is. So my zeros, what are my zeros? Do I have any? No. So x is equal to the empty set. Remember, that's how you have to answer it on Delta Math. And that's, I mean, the appropriate way to answer it anywhere. But and then vertical asymptote, I have 1 at x equals what? 3. Good. All right. So here's my number line. I have one number on it, and that's 3. Is this opened or closed? Open, because it's a vertical asymptote. Okay. So between negative infinity and 3, I can pick 0. The numerator is positive no matter what. Denominator, 0 minus 3 would be negative, so that's negative. And then If I pick 4 for the other part, the numerator is positive, 4 minus 3 is positive. It's positive overall. Okay, we good with that? I want to know when this is greater than 0, so that's when it's positive. This part right here. 3 to infinity. I never include my infinities. Do I include 3? No, I do not. That is my answer. Okay. We good? So they're not always long and complicated. All right, we're going to start number 4 together, because if I don't, then some of you are going to do some weird things again. So on number 4, if I don't factor it, it's not the end of the world. I can get the right answer. The problem is when you don't factor it, a lot of you don't get the right answer, so I don't want that to happen. I'm going to factor the numerator, can factor out that 4, gives me x plus 2. Denominator is x plus 5, less than or equal to 0. And then I'm going to give you a minute or so, a couple minutes to work on that on your own. You can work with each other. You can speak with your neighbors. That would be great. You feel judged. Why are they judging you? Why do you feel like she may have been judging you? That's correct. Yeah. I believe so. Let me double check what I have. Here, let me just work through it. Okay, let's see. So, all right, one of the questions I had earlier today, which was a very good question, was when I'm picking these numbers and multiplying it in there, do I need to consider this 4? And because he's positive, the answer is no. If this was a negative 4, then I'd have to start each thing with a negative. You with me on that? But since it's positive, I can just kind of ignore him, and it's okay, because I don't care about the actual value. So if I have a negative 6, that would give me negative over negative, which is positive. And then here, I'd pick maybe a negative 3. So that'd be negative, positive, which makes this negative. And then I'd pick 0, so I get positive, positive, which makes it positive. Okay? And what I'm looking for is when the function is less than or equal to 0, so it's negative and 0. Now, another good question I had was, now this person had this as, even though he had negative, negative up here, he had this as a negative instead of a positive. So his question was, because I'm looking for when it's negative, can I go from negative infinity to negative 2? And on this particular question, the answer is no, right? Because this is open, I'd have to skip over it. If this was closed, then I could, but this shouldn't be negative anyway, right? So we want the negative part right here, And as far as whether or not the 0 part, that should already be taken care of because you already did your open and closed. So we're going from -5 to -2. This tells me this is open. This tells me this is closed. Okay? We good with that? And make sure your numbers on your number line go from least to greatest. Just because you wrote -2 first doesn't mean it goes on the left down here, right? It has to make sense mathematically, or counting-wise anyway. Questions? We good? All right, we're going to do 5 together. So my zeros, well, it's, okay. I've got it 0 on one side. It's all factored. I can't reduce. Now I get to jump into the rest of it. Zeros, how many zeros do I have? 2. I got 1 and a -2, right? Vertical asymptote, I have 1 at x equals 2. So on my number line, I've got 1, 2, 3 things. -2, 1, 2. What do I know for sure is open? The vertical asymptote. This 2 is open no matter what. This says greater than or equal to, so the 2 zeros, those are closed. Everybody good with that? Because that's important that we know how to figure that part out. Okay, so now let's pick some numbers. I can start with -3. -3 minus 1 is negative. -3 plus 2 is negative, but I'm going to square it, so the second part in the numerator is positive every single time. -3 minus 2 in the denominator is negative. So overall, this is positive. Between -2 and 1, I can choose 0. So I'd have a negative. Second one's always positive. And then negative, which makes this positive. Between 1 and 2, I can pick 1.5. 1.5 minus 1 is positive. Second part's always positive. Denominator, 1.5 minus 2 is negative. Makes this negative. From 2 to infinity, I've got 3. So that's going to be positive, 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 positive overall. This is supposed to be greater than or equal to 0, which means positive and 0. It's positive here, here, and here, right? Can I connect this and make this one big thing here? Yes, because that's closed, so this is really one big thing. So I'm going from -infinity to 1. Never include my infinities. Do I include 1? Yes. And then I start back over at 2 and go to infinity. Never include my infinities. Do I include 2? No. Y'all, how many times do I say we never include the infinities? I say it multiple times a day, right? Please don't be the person that ever includes an infinity. Don't include the infinities. Okay. Are we good? I'm sorry, what? Oh, yes. Always. Okay. Any questions on this? Now, I'm going to draw something in. And just like on the other one, I don't want you to do it because I don't want you to think you have to do it. And I don't want it to add to confusion. I'm just going to show you what we kind of know about this function. First of all, I know that I have a vertical asymptote right here, right? I also know that my function starts positive out at -infinity, and when it hits this 0, it has to stay positive so it bounces up, right? I don't know how high it bounces up. I don't really have a y-axis or a scale anyway. But then it's going to hit this 0, it's going to cross through because it's negative, and it stays negative, and it's going to hug that asymptote that way. On the other side of it, the function's positive forever, right? And so I have either, would I have a horizontal asymptote here? Is this top heavy, bottom heavy, or tied in degree? It's top heavy. It would actually give me a parabolic asymptote. I don't care. We wouldn't have to do that anyway. But what I know is if it's positive, it has to look like this, and then I don't know what happens to the other side, but it stays positive somehow. So it tells me stuff, okay? The other thing is this. You see how on this it alternated, and here it alternates, and on that first one it did? This one didn't alternate, right? It was positive, positive, and then negative, positive. And that's because, look what happened there. It was the bounce. It's because I have a squared there. On this other one that didn't alternate, right here. Right here. I had positive, negative, positive, positive. Right here, it was squared. So that's where it doesn't alternate. I'm showing you that because once you fully comprehend this better, which I'm pretty confident we're not there because most of us didn't comprehend it at all last week. So we're not there yet, all right? But when we get there, we can understand if none of my factors are squared, it's just going to alternate, and I don't necessarily have to find every single sign. You with me? But for right now, I want you finding the whole number line and go from there. All right. Let's do this last one together. Zeros. What are my zeros? None. Empty set, right? Vertical asymptotes. I've got one at x equals what? 1. Make my number line. I've only got one thing on it. That's a 1. Is the 1 opened or closed? Open, because it's a vertical asymptote. So between negative infinity and 1, I can pick 0. Numerator's positive. Denominator, 0 minus 1 is negative, but I'm going to square it, so denominator's positive no matter what. From 1 to infinity, I can pick 2. Numerator's positive. Denominator is always positive, so it's positive. And what I'm looking for here is when it's negative and 0. Is it ever negative? No. Is it ever 0? No. So it is no solution. The function basically looks something like this, with that being your x-axis. Okay. What questions you got? All right, so we also have to be able to do this from a graph, which is actually easier, but sometimes, again, y'all overanalyze things and then weird stuff happens. All right, so I want the function to be less than or equal to 0. That means when it's negative or 0, and that means when it's below the x-axis, right? So when does this function begin to be negative? -3, good. Remember, we are looking at the y's, we are talking about the y's, we are writing about x. So all of these y values are positive. My y values start being negative right here at -3. I do not include that because that's an asymptote, so I'm not actually negative when x is -3. And then it's negative until we get to what? -1. Do I include -1? Yeah. At -1, the function is equal to what? 0. And this does say negative or 0, so in this case, yes. Okay? Then when does it start being negative again? Or when is it 0 again? 2. So do I include that? Yes. And then it's 2, 3. It's very tempting to want to say negative infinity, right? So that's when you have to remind yourself, yes, y is going to negative infinity, don't care. Looking at my x's, 3, and I'm not including it. Okay. Everybody okay with that? All right. Let's look at B. F of x is greater than 0. That's when it's positive or above the x-axis. When does this function start being positive? Negative infinity. Very good. Way out here, the function's positive. So negative infinity. It remains positive until it gets to -3. And then it becomes, I don't include -3 because it's an asymptote, right? -1 to 2. Not included. But those are zeros. I included them over there. Why am I not including them? Good, because of the sign. Because it doesn't say greater than or equal to. Very good. So these are open. And then it's positive again, starting where? 3 to infinity. Good. Yay. All right, now C asks me for the function being greater than or equal to 1, which is the asymptote. So really kind of the same thing. It's greater than or equal to 1 starting out at negative infinity, going to -3, right? None of this in here counts because it's all this is below 1. Now, this one over here, and let me erase some of this so that you can see what I did, because I want you to see how clearly this isn't anywhere close to the asymptote yet, but it's getting closer and closer and closer. Here, it looks like it actually touches it. I wish I had a better picture, but these are very hard to make, and so I just do the best I can with what I got. And this actually crosses the asymptote at 6, but stays real close to it. And you can kind of tell, if I gave you a real question like this where I expected you to recognize that without me helping you through it, it would be a much better picture and much more obvious. Okay, so don't worry about that. But it does cross, and I can't even do it right on my board, it does cross at 6, because remember, you can cross a horizontal asymptote. So negative 3, and then 3 to what? 6. And I'm not including the 3, but I would include the 6, because it passes through, and that's when it's actually equal to 1. Exactly, because it's below 1. Now, I will tell you that for the I don't know that I have seen anything from College Board that expects you to do this. We're really usually more talking about positive and negative, but I threw this in here just so we could look at it. Okay, we good on that? What questions you got? Okay, so listen, while you're taping, shh. I have students all the time on quizzes, sometimes on tests, write a little note at the top that says something like, I was absent this day, to which I say, good for you. I don't quiz you the day after we learn something. I project this every single day, and it's in Canvas. When you are absent, it is on you to get what you missed and make sure that you stay caught up, okay? Because you have a test on Wednesday. Remember, you have your Albert stuff, you have your AP Classroom stuff, you have your quizzes returned back to you, your assignments that you hopefully actually did and checked, and your notes. What I want you to do now while I hand out the assignment is turn to page 33 in your ISN. Listen. Some of you can listen when your mouth is running. Title it First 6 Weeks Reflection. And that's what it is. And this is a very open-ended question. I want you to reflect on you and this course from the first 6 weeks. Do you feel like you did everything you could do to be successful? Maybe the answer is yes. Is your grade where you would like it to be? What could you do differently? What will you do the same? Whatever you want to write about, but reflect on that. And you can't do that if you have nothing in front of you. So get your ISNs out and turn to page 33.